Hadirin sekalian, burung merbah di hujung dahan terbang tinggi membawa pesanan. Dengan hormat dipersilakan panel jemputan naik ke pentas. Kini mempersilakan Encik Ong Chin Hu, CEO Temasek Teknologi, naik ke pentas meneruskan slot yang kedua. Dipersilakan.
Hi, good evening. YB Tuan Chang Lih Kang, Minister of MOSTI, Dato' Ruzia, DKSC of MOSTI, Dato' Peter Ng, Prof. Dato' Dr. Hamisa, VC of UCSI, Tan Sri Dr. Zakri, and also Prof. Pang, Night VC for UCSI as well. Thank you, MOSTI and UCSI, for inviting me over to give a talk. It's my pleasure. First time for me to reach at UCSI. I have seen a hall full of people. Really my pleasure to be here. Thank you, everyone. So today I'm going to, as I think YB Minister just mentioned, I think he talked about the big picture of the policy about what MOSTI is going to do for you guys. And I'm going to zoom in a little bit on the IC design, particularly in the semiconductor field, which is also under MOSTI, right? One of the area of the key pillar under MOSTI. So I'll talk a little bit more in details about why, like what YB just mentioned, why Malaysia want to move up the value chain, especially in the IC design perspective, right? I'll give some history. I think YB kind of stole my idea already. Or we have Ensync, so he already gives some background. Just kidding, just kidding. Yeah, so Malaysia, why we have a good opportunity in the IC design? This is because, as YB has mentioned, Malaysia has started about 52, 53 years ago. In fact, 1972. There were 8 companies from the US, from Europe, and from Japan, namely like Intel, HP, Renesas, who came to actually Penang, still Malaysia, who started their manufacturing many, many years ago, 53 years ago, ladies and gentlemen, right? That's where Malaysia EE industry rooted. And that's basically, in fact, we are actually much, much earlier started compared to countries like Taiwan, even South Korea, even Singapore. So we started way ahead. As YB has mentioned, Intel Malaysia is the first Intel facility outside of United States. Okay, so this is where we started, and for the IC design, the industry has actually started about 20 plus 30 years ago, because when all these companies have been doing manufacturing for 20 over years, people move up the value chain again, right? From manufacturing, they say, hey, we should start to do some small IC design. That's where, when I joined the company around year 2000, was sent to the US for a couple of years and actually bring back the technology. That's also under MOSTI, technology transfer, right? So yeah, that's how we actually started. So let me dive into the IC design field. I'll start to introduce a little bit more, since I think there are a lot of, I think the main participants here are students. Obviously, MOSTI people are the expert already. So but I will try to explain to the students level, right? So you can see in the semiconductor industry, we are divided into, from IC design, that's basically the beginning of the semiconductor industry. You really need to have a chip first, okay? As YB has mentioned, so that is basically the brain of the electronic system. From IC design, you have the foundry. I will give some example later. And then you have the assembly and test, and you have the EMS and OEM. So in Malaysia, I'm not sure you guys are aware, from the semiconductor perspective, we are actually one of the top in the world for back-end OSAT. OSAT stands for basically outsourced assembly and test. You can think that way, right? So assembly and test, we are actually exporting 13%, 13% of worldwide capacity of the industry. The whole industry right now for semiconductor about close to $700 billion US. As YB slide just now has indicated as well, is at a very high CAGR growth, targeting reaching $1 trillion US in 2030. Okay, so in the whole, maybe still the first slide. Normally I try to give a more longer explanation. So why IC design is important? So let me give an analogy. I think how many of you have an iPhone using iPhone or iPad before? Please raise your hand. So maybe half, right? Yeah, YB himself as well. So I give an analogy of an iPhone, right? If you use an iPhone, let's say this iPhone is 17 or maybe 16, $1,000. How much revenue from this $1,000 come to IC design? How much go to foundry? How much go to assembly and test? How much go to the EMS? So in the IC design itself for Apple product, most of the product actually, Apple do their product design, including IC design themselves. Okay, I have a lot of good friends in the Silicon Valley working for Apple. So IC design, in this sense, $1,000, close to $500+ is in the product and IC design itself, the value captured. Another 20+%, meaning about 100+, captured by the foundry. In this sense, Apple using TSMC. It's the world's largest foundry in the world, right? I mean, world's largest foundry, which is in TSMC in Taiwan, right? So they capture about 20+% of the market value of the $1,000. And the assembly and test, which is traditionally Malaysia's strength, right? How much they capture? Roughly about slightly high single digit, okay? So high single digit of 500, yeah, basically about $50 max, okay? And then the assembly, people like Foxconn, who is basically the main assembly, system assembly for Apple product, right? So they capture also single digit only. But because the volume is so big, even Foxconn is so huge. And obviously, who is bigger? Of course, it's Apple, because they are in the IC design, the product design. And the final 10+%, maybe you may do your max and say, hey, why Mr. Ong missing some percentage, right? So the last 10% go to the distribution, the sales and marketing channel, right? The distribution and marketing and so on. So 10+%. So that's the whole value chain. Why YB was saying that, or why our government is trying to push to go up to the value chain, is because the biggest of the value is actually in the front. And if you are in the IC design company or product company, you can decide which country or which company is going to do your assembly and test, right? So if you are the product company, you can decide today I want to do the assembly and test in Malaysia, but maybe tomorrow I want to do in Thailand or do in some other country, Vietnam, because it's cheaper. So that is why IC design company or product company is extremely important. If we don't capture this, even though we have been very, very strong in the OSAT, capturing 13% of the worldwide market share, this may one day go away. And how soon this can be decided if the company want to move out the OSAT? Any guess from any one of you? Maybe I give a few options, choice for you to choose, right? 1 month, 3 months, 6 months, or 1 year? Any rough guess? How soon people can move the manufacturing from one location to another location, or from one factory to another factory? Okay, maybe to no mic, right? Maybe I answer the question myself. So it's between 3 to 6 months. So this is actually quite alarming. That means if people really want to move out from company A to company B, from location A to location B, people can decide pretty soon. And that is primarily driven by cost. Because as the advancement of technology and automation, as YB has mentioned, there are a lot of robotics. I think UCSI video also showed that. So people can actually move quite fast because there's not so much technical skills that's actually retained by the team, right? It's mostly in the robotic automation that actually the company has already. And these machines can be moved. So in this sense, from the IC design, we are basically the product or IC design company, the NASIC itself. And in that IC design, we also subdivide into a few categories, right? One of it is basically the product company. We also divide into fabless and IDM, right? IDM is integrated device manufacturer. So this company's example, I will give two. One is Intel, meaning they do their own IC design product. They also have their own fab and assembly and test. They do everything themselves. That's why they are called integrated device manufacturer, right? Whereas fabless is like Apple. They do the product design, but they don't do the foundry fabrication. They don't do the assembly and test. They outsource it. Same like our company. We are actually a fabless IC design company. Most in the world is actually fabless. So another example of the IDM is like Samsung. So they have their own fab. They also do their product design. So it's a bit less. And there are companies like Infineon and all this more niche. They have their own fab as well, right? But most of the IC company, biggest company in the world is actually fabless, like NVIDIA, right? As we all will know, they are the top in terms of market capitalization, right? And then there's an EDA tools company, basically like what you are using. If you are using Microsoft Office to do your day-to-day work, EDA tools is what we IC design engineers use the software tools to do the design itself, to do the IC, to create or develop the IC, the integrated circuit, right? And then there are IP cores company. I think YB just now has mentioned also a company very famous called ARM. So they are the IP company. So they provide the components in the IC that you use to design your IC. So in this sense, basically ARM provide the ARM cores, which is mostly used in basically your mobile phone. In the world, about 90 plus, close to 100%, all your phone are powered by ARM core. So they are providing this IP. But the phone, the chip can be from Qualcomm, can be from other company, which is using the IP from ARM. So that's how the IC design industry is about. And then the design services, basically as we are the product company, during the peak, let's say when we do one project, we need a few hundred engineers to do this particular IC. So during the peak time, you may need additional 50 or 100 people, right? So you may not hire to the peak, but you use basically design services company. So in the world, actually the design services company, India has the largest basically design services company, right? In terms of number of people and so on. In Malaysia, we have one company called Opstar. They are listed in Malaysia, KLSE. On the ACE board, they are the design services company. So they are the first IC design company listed. And then in the foundry, we obviously have like TSMC. And in Malaysia, we actually have multiple fabs. So we have Silterra in the north. And then we have obviously MIMOS, right? And we have actually XFab in the Sarawak side. So XFab primarily focus on the power electronics side. And then Silterra focusing on the MEMS and so on. And automotive as well, right? And similarly for MIMOS as well. So there are three fabs here. But fab is a very, very capital-intensive industry. Therefore, from my view, I think we should focus on the niche and not go and basically compete with like TSMC. That's probably not a good choice, I think, in my opinion, because it's too huge capital investment. And assembly and test, as I think YB has mentioned also, advanced packaging is very, very important. So we really hope, right now, to be frank, I talked to all the big companies doing packaging. At this point, they have planned, but we don't have advanced packaging yet at this moment. But I think as YBS has mentioned, I think this is one of the national agenda that I think is very important for us to have advanced packaging capability. Or we hope that in the next 2-3 years, we will really have the advanced packaging capability. I think this one will need YB and the team to help, and also KE and so on. So in the testing side, we are rather strong in the world, right? So we have multiple companies like Inari and so on, very strong in testing, CASAM, MPI, all this, right? So, and in the EMS, we are also quite strong. We have a lot of company, be it MNC and local company, and then we have a lot of automation company, right? Like Pentamaster, Great Tech, and so on and so forth. Okay, so this is basically to introduce you the whole value chain of the semiconductor. And since I'm from the IC design industry perspective, I'm promoting a little bit more IC design. Okay, next slide, please. So as you can see, another thing I want to highlight is basically to YB as well. So in KLSE, talk about stock market a little bit, so maybe make you more awake, since it's a pretty late talk, right? Not only on pure technology, a bit boring, right? So in the KLSE, right now, all the technology company adding together the market capitalization of the whole, comparing to the whole KLSE market cap, how many % you think technology company comprise of the KLSE total market cap? Any guess? I give a few options again for you to choose. 10%, 20%, 30%, 40%. Just think, no need to, or you want to shout, the answer is fine too. Any guess? 10 to 40. 40, okay. Any other guess? 10%. So the answer is close to 10% only. And you can imagine how big is the US tech company on the total market cap. So I'm not going to give you the comparison, but what I'm trying to say, we have a lot to do actually in Malaysia to push this. And again, we will need YB and the MOSTI team, Dr. Ruzia, to really help how to push more technology, because technology, as YB has mentioned, with the era of AI, advanced artificial intelligence, actually more and more of your life will be using electronics products one way or another. You may not be actually noticing you are using it, as you are actually taking a video. Those videos may be already uploaded to your cloud. Everything behind is actually powered by the chip. Of course, at the top level, the top layer is actually the software and the AI, but underneath all the AI, you need a lot of chips, right? You need a lot of semiconductor, you need a lot of integrated circuits. Therefore, this is the area for future, current and future, right? To power the whole thing. And you can see in the IC design sector, I list it down a little bit. So we have the product company, and we have obviously some large company from a foreign company. And then you have the EDA tools like Synopsys, Cadence, and Siemens, and IP cores company. And then we have the design services company. So in Malaysia, we are quite lucky. We have quite a lot of those companies in Malaysia, be it in the Klang Valley and also in Penang. So we should really capitalize and really move more people, and hope after this talk, some of you are interested to do IC design, or can talk to your professors to see how do you actually get into be it IC design or AI or computer science, or in that sense. Obviously, like what YB has mentioned, there's always the need for accountant, business people as well. But I think if you are interested in the STEM, this is one of the areas, very great opportunity for all of you to participate in that. Next slide. So again, overview of what IC design is. I try to use a more simpler terms to let you understand what is basically IC design, right? So first of all, if you want to start a system, think maybe data center, right? So what is the system requirement from the actually software, from the system usage perspective? That's how people start to specify the system. Then from the system requirement, you need to specify to both software and the hardware requirement. From the hardware requirement, then you will go down to the IC. What is the specification of this IC to support your system needs? So this is the first thing, the specification. So this one typically is the system architect, we call, who actually design the whole system, think about it in very detail, write up the high-level specification, and then the IC design architect will work with them to translate the system spec to the chip spec. Because this, you think about it, it's a big house or big factory. You go into the core of the machineries, right? You think from that angle, right? That analogy. Then the IC design architect is the one that actually come out with the IC spec. What is the input requirement? What is the output requirement? What is the performance? What is the workload that will be running on these chips, right? So from there, then we are going to do the IC design. This is a little bit detailed, but I will go through very, very briefly. So first of all, you actually, from the conceptual, you have the IC specification, just now as I mentioned, from the system architect, from the IC architect. Then you actually start to code. And the good news is, again, like what YB say, we have the AI. So now, engineers actually, for example, I mean, I can tell the tool's name, right? The Cursor AI, for example. So you can actually use the Cursor AI to help you read the spec in and output the design. Interesting, right? So what are you doing as an engineer then? You are going to just debug the code. So traditionally, when my time, so it's no AI. So we need to write our own code. Write our own code, then we run the tools, the EDA tools just now, I remember, the software tools, and validate your own design, right or wrong, your design. Now, AI can help you split the first version. Most likely, it's 80% correct already, okay? I will say. So you have 20% of work. But again, my own experience, you go through the code sometimes, if you are a very experienced engineer, you write the code sometimes still faster than the AI. That's why, like what YB say, humans still very important, okay? So we cannot eliminate the engineers. So no worry, I have some of my team are here, like 10 plus of them here, so no worry, okay? But AI can do 80%. So why we want to use AI? I think YB mentioned very clearly, again just now, don't be afraid of AI. I talk to my engineers here. Don't afraid of AI. What we want to see is improve the efficiency. Right? Why afraid? Right? 80% done, you still have 20%, but 20% is the tough one that AI cannot do. That add value is the one that you add to the company, to yourself, right? To the economy, to the country as well. So, but right now it's 80%. So we'll see how far they can go. But typically, the last 20%, 10% is the hardest. Everything is like this. The first 50% is normally quite easy to achieve. So AI now can do 70, 80%. So quite amazing to do the coding, okay? So from there, then you need to validate your designs, as I mentioned. Then you translate that to a physical domain. Because when we go to the fab, like TSMC or Samsung, or go to Silterra, right? What you are going to give them is a physical file. It's no longer a conceptual code, right? It's not a code. It's actually a physical design file. The physical design file just looks like this, the physical layout, right? Exactly, the transistor is at the north, the memory is at the center, and the pad, the I/O pad is on the corner of the chip and so on. So you need to actually translate your design through the EDA tools, through the software, to this format that the manufacturing will understand, that the fab will understand. Okay? So, fabrication. So, fabrication, I think my MIMOS friend, Dr. Nordin, is more expert than me, but let me explain a bit. So, fabrication is what? So, during the IC design, you split the file. The file will say, just like, I give an analogy, I like to give analogy, right? Just like making kueh, you have multiple layers. So IC also like that, multiple layers, but a lot more layers. So you actually give the layer, the file that define the layer to the fab. So it's a file only. Everything, that's why IC design is very interesting. Traditionally, when I talk to a government officer, they say, hey, you need to invest a lot of CapEx, big factory, big machine. IC design, the investment is in here, actually. And of course, the software tools, right? But really here. So when YB, if you visit us, only office only and computer, nothing to see. Of course, the end product is there, but seriously, nothing much to see, right? So not so interesting. But the value is 50+% YB. So yeah, welcome YB to visit us. Okay, so the fabrication, again, go back, really is a layer of information of the mask. We call mask, M-A-S-K. The mask is telling the fabrication company, like TSMC, 1 layer, 2 layers, so like 30, 40 layers of mask. Then combine this, become the wafer. Okay, so that's how come up with a wafer. Then from wafer, you need to do a testing. Test first. Then you mark which die is good, which die is bad. Then after the die is marked, then you go to assembly. Assembly is basically cutting the wafer into the singular die. From the die, then you go to the packaging. Packaging, I believe, all of you may visualize better already. Typically, it's black color. Yeah. So the black color package, that's called packaging, not our box drink punya package. So it's a black color packaging. That's the IC semiconductor called packaging, right? Typically, it's black color. So you can see multiple different types of packaging. I'm not going to in details. So there's the assembly. So after the final product is out with the package, what else you need to do? You still need to do testing. Test the chip is good or bad. So that's why we have testing, the OSAT, right? Remember, assembly and test. Test the part. It's good, then you ship. Ship to who? Ship to a company like Jabil, Foxconn, Plexus, this type of company. Then they will put this chip plus the other components into the board, into the system. Then ship this final product, stamp the name. That's why this company, they are doing like a kind of a system assembly for other companies, right? They don't own their own product, right? So they do company for, when they do the final assembly, product can be for HP, for Dell, for Apple, and so on and so forth, right? So finally ship to the destination to any country they want. So that's the entire value chain of the IC design. I hope I give you some high-level understanding. Next slide. Okay, so I go in a little bit of foundry. So as I mentioned, my personal view, of course, foundry is a very capital-intensive market or industry, right? And it's going very, very fast as well. Very, very fast, huge investment. Every process technology, if you're talking about advanced process technology, is tens of billions, sometimes hundreds of billion US dollar, right? So currently, distant number 1 is TSMC. Samsung is number 2. Kind of Intel is coming up, but yeah. So I was ex-Intel as well. So we have like in China, and then of course in US there's Global Foundries, and then there's in China there's a SMIC, SMIC, right? Those are the main foundry. And then for memory, you have of course Micron, Samsung, and so on. So it's a different, you see fab also differentiate. So my view is basically, of course we have the fab equipment, or Lam Research is a huge company. ASML from Europe is also a huge company doing the EUV machines and so on that's used in the fab. So that's very, very specialized. So if you like physics, all this, these are the companies that you can go into, right? And for specialized material, we have a Malaysian listed company again called Franken. So what they do is basically they do the specialized machine kind of maintenance basically for the foundry, right? So they are doing the maintenance of the machine. It's also specialized. It's not anyone can just go and clean these machines, because this machine is tens of million US dollar, sometimes 100 million US dollar. So you need a specialized skill set to clean. And Franken is a very profitable company, by the way. Next slide. So in the assembly and test, this is our traditional strength in Malaysia. So you can see that the IDM and OSAT, IDM, they do themselves. Remember what I mentioned earlier? They may do their own fab, they do their own testing, right? And we have actually OSAT, quite a big MNC OSAT in Malaysia as well, like TFAMD. Then we have 𝐓𝐄𝐄𝐈𝐏 and primary ASE over in Malaysia, and then SPIL as well. And then local OSAT, we have a lot, right? KASEM, Minari, and so on and so forth. And test equipment is another area that Malaysia is super strong, right? So we have actually a world-class company like 𝐷𝐻𝐿𝐒, like Dato' Chu, I know him pretty well. So they are actually the world leading vision ATE tester company in the world, right? So for vision testing, vision inspection. But again, testing is a lot of subdivision also. So they are in one area only, right? Not all the area. So there are many, many other companies, and then like some are the automation expertise, like 𝐷𝐻𝐿𝐒, Pentamaster, and so on and so forth. They are doing the automation. That means automation meaning they set up the production line. Like 𝐷𝐻𝐿𝐒, okay, everyone know Tesla, right? So Tesla cars are pretty good, right? So, and the assembly line that manufacture Tesla car actually is built by Malaysia. So again, Ybrs now mentioned, Malaysia technology is actually quite good, but people don't know. So 𝐷𝐻𝐿𝐒, for example, actually set up the assembly line for Tesla to manufacture your car. You see? So you say, hey, is it Tesla good? Of course, Tesla is very good. And local company, Malaysian, also very good, right? They actually supply to Tesla in the US to manufacture or to anywhere in the world, right? To Europe, to China, to develop your cars, actually. So underneath, there's a made by Malaysia content as well, in a way, right? Of course, people see Tesla, don't see the local company, but again, I want you to be aware, and like 𝐷𝐻𝐿𝐒 CEO is a multi-billionaire. So I want to motivate you also from monetary as well, right? So if you can set up your own company, be it in IC design, be it in automation, you can be multi-millionaire or billionaire, right? Even billionaire, right? Like 𝐷𝐻𝐿𝐒, right? Dato' Chu also billionaire, right, in Malaysia. So yeah, I think there's a lot of possibilities I want to kind of highlight. Of course, their traditional business also can be billionaire, a lot in the Klang Valley. But from the northern side, a lot is a technopreneur to be a billionaire, right? Okay, next slide. So we hope soon we will have multi-billionaire or billionaire from the IC design industry, right or not? Okay, next. So this is my view of the local semiconductor industry, right? Our strength and our area to improve, right? So again, I think from the foundry perspective, we should focus on the niche area. This is personal view, I think not a YB view. This is my personal view. So from the fab side, I think we should focus on the niche, because we should not head on with the like Samsung, TSMC, all this, but niche area like Silterra, X-FAB has been doing, like power electronics, MEMS, all this is the right area that we can continue to focus. This is important, right? So, but this is an area that is not easy to attract big foundry to come in, actually, in my opinion. To be frank, one of the largest foundry, I cannot name the names, they actually contacted me, asked me for input, right? Should they come into Malaysia? And so I give them a neutral view, right? What's the good and the bad? Obviously, there are a lot of good stuff, of course, but there are also certain things not so pro from Malaysia perspective for the foundry. And then packaging, I think I fully agree with YB. I think advanced packaging is the key, one of the key area, but again, also need a lot of investment. So not cheap also. Yeah, do high tech is never cheap. Yeah, never cheap. When we say we do cheap, but it's never cheap. Okay, the different spelling, CHIP cheap and CHEAP cheap. So never cheap. So advanced packaging, I think is important. Packaging, we have been pretty strong, but the advanced packaging, we are still lacking at this point of time. But the government, I think, is working with the private companies. Like I talked to like Inari CEO and ASC and so on. Yeah, I think they are working, have some initiative, which I should not disclose. Let YB talk about more. Yeah, and then the EMS side, we are also pretty strong. IC design, we have the foundation, pretty good talent. That is the key thing. But a lot of time in the past, all these talent are working for foreign company. And right now, I'm glad part of the local IC design ecosystem. Of course, all of us from MNC before, like 20 over years in MNC. So now we create this, we hope more of you guys not only joining the MNC, but also join the local startup so that we can actually push this further and further and further. Right, okay, next. This is what I think a bit of advertisement, what we have done as a local company. So we have actually, first product we do is actually not that tough. It's quite a simple, I would say, 32-bit microcontroller. I think all the academia here. So what we are doing is actually the chip that is controlling the smart meter, right? So we are selling millions of units in mainland China. We went to Hong Kong last 1-2 years. So we want to go into more places, right? Just 1-2 minutes advertisement. Then I will go to the third chip, maybe just skip the second one. So the third one is one of the first data center chip. So this chip is used to, actually we call it a baseboard management controller. So for example, let's say Datuk Ruzia took a video of the event today, right? So she wanted to upload it to, let's say, Google Drive or Microsoft OneDrive, for example, right? So in your, as a user, Datuk Ruzia just press 1 second, true or not? Very simple. What happened behind the scene is this, basically. So of course, let's say if it's using Google Drive, Google software will interpret this, there's a demand to upload a 100 meg file to the cloud. So in the data center, the software will determine which is closest data center to Dato' Ruzia. Let's say if it's from here, UCSI, obviously I suspect it will be Cyberjaya area, right? So the data center there, let's say Google have a data center there, then we'll go to the data center. In the data center, you can imagine many data center rack, right? So in the rack, you have many motherboards, just like this, right? In the motherboard, the chip called BMC, we will need to determine first, why is it called management chip, right? So we will determine which motherboard, which CPU will be free to execute this workload requested by Dato' Ruzia, right? So first, basically distribute the workload. Because you have 10,000, 100,000 of this motherboard, actually, right? That's the first thing. Second thing, very important, security. Because if Dato' Ruzia is uploading a very confidential or personal stuff there, definitely Dato' don't want this information to be leaked out by anyone, right? And Dato' Peter want to take a look, cannot, right? Of course. Yeah, so security is very important. If not, let's say Dato' Peter have access, then he can just access anybody's information. Because software is just the first layer. Really, the hard layer is actually the IC that's actually protecting all the information, right? That's security. The third function of this chip, in short, is basically like preventive maintenance. Because after you run the data center for years, you need to know which particular motherboard may be coming down soon. Because data center, you want to have 99.99999% uptime all the time, right? Minimum downtime. 100% so far cannot be done yet. So you need to challenge me why, but that's for a separate topic. So yeah, so that is basically the BMC in short, the function. So we actually tape out this. This is a TSMC 12 nanometer product. So it's pretty advanced product, right? So for comparison, for example, Silterra is in like 130 nanometer, 90 nanometer. So ours is basically 12 nanometer, right? So okay, in terms of process technology. Next slide. So last will be a 2 minutes advertisement again, our corporate video. Yeah. Founded in Malaysia in 2021, Temasek builds on a strong legacy of semiconductor innovation with a bold vision to become Southeast Asia's leading provider of custom ASIC, SoC, and embedded software solutions to serve the global markets.
At Temasek, we believe silicon drive innovations that elevate human society and build a sustainable future. We deliver advanced and scalable AI and ASIC solutions with our critical IPs including high-performance CPUs, versatile NOCs, chip-to-chip interconnects, and CXL technologies.
Our expertise spans the full semiconductor value chain, from advanced IC and IP design on both ARM and RISC-V compute subsystems to embedded software and systems, including virtualization, firmware, BIOS, and edge-to-cloud integration. We also deliver end-to-end silicon productization, from post-silicon validation and advanced packaging to high-volume SoC production.
At Temasek, we don't just build SoC and IP. We build complete software ecosystem that unlock full potential of silicon. Our team delivers performance-optimized, security-hardened, and highly scalable solutions that power applications across AI, embedded system, cloud infrastructure, and beyond.
At Temasek Technologi, we don't just design chips, we deliver complete solutions, powering the next generation of intelligent semiconductor technologies for AIoT, edge, data centers, and AI products.
Our vision, fueled by the spirit of tenacity, is to deliver scalable, efficient, and more importantly, transformative silicon platforms for the world.
Driven by tenacity, defined by innovation.
Terima kasih yang tidak terhingga di atas